Okay, 203, I think we can start the presentation. Thanks everyone for joining the Glaze webinar series. Today, we're gonna have a talk a little bit different than what we normally have. We're gonna be talking about data sharing. So my name is Erico Matos, and I'm the Executive Director of the Greenhouse Lighting and Systems Engineering Consortium. And today I'm gonna be your host and also a co-presenter. I have here with me, Kenneth Tran from COIDRA. Kenneth will provide a brief introduction on himself in just a second. Just before we go to the introductions, I would like to let you know that a recorded version of this webinar will be available at the Glaze website after this presentation. So you can go back, if you have any questions, if you want to see anything else, you can go back and you can see this presentation again. I would like to remind you that if you have any questions throughout the presentation, please use the Q&A box to submit the questions. We're not going to stop the presentation along the way. I'll be presenting the initial part, and then Ken will present the second part with a live demonstration afterwards. But please submit your questions along the way. At the end, we're going to have a Q&A section where you can go back and answer all your questions. Ken, would you like to provide a brief introduction on yourself before I start the presentation?
Sure. Hello, everyone. This is Ken, and I'm the CEO as well as CTO of a startup, a tech startup for controlled environment agriculture called COIDRA. And our company focuses on building the autonomous greenhouse program and applying the latest technology and data science, machine learning to the fields of controlled environment agriculture.
Perfect. Thanks, Ken. So without further ado, let's go ahead and start the presentation. I will share my screen. Ken, can you confirm if you're seeing the correct screen? Is this the main screen?
Let me see. I have so many windows open. Yes, I see yours.
I normally do this confirmation for the speaker, so I'm glad you're here with me today to confirm. Thanks for that. All right, everyone. So thanks for joining us for the webinar series today. And like I mentioned, we're going to be talking about Controlled Environment Agriculture Open Data Project. This is a project that started in 2018 after a meeting on the Controlled Environment Committee of the USDA, the NCER 101. At that meeting, researcher Dr. Cherry Kubota from The Ohio State University, she raised a question about the importance of sharing data sharing in the CEA field, on the Controlled Environment Agriculture research and commercial world. So at that time, she just raised her voice, made a call for action, and some people decide to work on that, volunteer to work on that. And since then, we form what we call a task force, which is formed by myself, and I'm working with Glaze. I'm the Glaze Executive Director. Kenneth Tran, who is my co-presenter here today, now at COIDRA, CEO of COIDRA. Dr. Cherry Kubota from the Ohio State University. K.O. Harbeck, Dr. K.O. Harbeck at the USDA ARS. Melanie Yelton, which is now at Plenty, and Yang at Purdue University. So we were the original people working in this project. Since then, Tim Shelford from Cornell has also joined the task force. And we've been collaborating with this multidisciplinary group to bring the CEAOD project out of the paper and really implement and facilitate data sharing in the CEA industry. I would like to start with an example before we go to the AI and the importance of data sharing, provide a real example on what can be done. So in 2018, the University of Wageningen in the Netherlands launched the first autonomous greenhouse competition. And that competition was intended to demonstrate the capabilities of an artificial intelligence-driven greenhouse. So there were 5 teams from around the world competing to grow a full cycle of a cucumber crop remotely, competing against themselves using different AI's approach, but also versus growers. So there was one of the teams, was a team of Dutch growers at the field growing these cucumber plants. With those teams, they had access, each one of them had access to an identical set of greenhouse, so a space of greenhouse, high automated greenhouse with several sensors and actuators that they could sense the environment. They could do some of the control remotely, and they could make adjustments as well. But the goal was for the AI to make decisions on how to control the environment and some of the crop production traits as well. They also had this competition now in 2020, was just finished, where they did was cycle for cherry tomatoes. So let's take a look what happened. Very interesting information to share here. In 2018, during the first edition of the Autonomous Greenhouse Challenge, Team Sonoma was the winner. And Kenneth Wren here with us today, he was part of that team. I'm sharing this table here. We just showed the net profit. So they're competing to optimize several things. You can do sustainability, you can optimize for sustainability, you can optimize for net profitability, or you could do both. In this case, Team Sonoma was the only team that was able to beat the Dutch growers. So you can see here on the highlight part of the table, the net profit from Team Sonoma was 24 pounds roughly per meter square of greenhouse versus euros versus 21 euros from the Dutch growers, and all the other teams were behind. Very interesting, in 2020, during the second edition, all the 5 teams using the AI algorithm, they were able to beat the Dutch growers. And actually, the teams that come on top, they did quite better. They did twice the net profitability than the Dutch growers. So it was very interesting to see how much this field was able to evolve in just 2 years, with more people dedicating resources and dedicating AI resources and personnel and funds for the CEA industry. So keep talking about AI. Just a quick demonstration and explanation on one of the definitions of AI, which I think pretty accurate here. AI would be the computer's ability to learn through its own experiences and solve problems. So that's what I would like to do. That's the final goal of this whole project with data sharing. Is to build a database where computers would be able to access this information to learn by themselves and then start to solve problems by themselves. A few examples on what has been in the industry. I think most of you here on this call might be familiar with the IBM Deep Blue. That was the major AI that broadcast and was mainstream, where the computer beat the chess player Garry Kasparov in 1997. And that really brought AI to the whole world. Since then, we've seen many applications in the real world today. So the self-driving cars, I think everybody's aware of that technology that Google has invested a lot. Now all the Tesla cars are working in the self-driving cars. Most recently, this program AlphaZero was an upgrade and improvement on AI for the gaming world. In this case, the AlphaZero computer, the supercomputer, he was able to learn how to play chess in 4 hours, and then he beat another software that was leading the competition, beating all the humans. So they really could learn by themselves with no human intervention. And that shows the potential and the capabilities of AI in the real world. And then another example is the agriculture world, most on the open field. There is a lot of examples now, people using AI on the open field. Some of the examples they call the identify and spray for weed control. So by imaging analysis, appliers can now identify what is weed and spray some sort of herbicides, very target, so you can protect the environment and use resources as well. And also nutrient deficiency, which can be detected through imaging, and then you can do target adubation on the field to make sure you have certain levels. One time you know the deficiency, you go very spot-oriented, high precision, and you provide the nutrients that are required for this crop after you're sensing what is needed. Also made here a list of 10 applications that are on our day-to-day lives. I don't know if everyone here is familiar with that, but AI has been used and successfully and everywhere on marketing, banking, finance, agriculture, like we mentioned, healthcare, gaming, space exploration, autonomous vehicles, chatbots, and artificial creativity. Those are some examples. From those 10 examples, I just would like to highlight 3 or 4 of them and how they could relate to our work on the CEA systems, on the greenhouse industry. So for example, on marketing, AI is used to search for products without knowing the names. So I believe almost everyone here on the call today, you're trying to look for a certain product or center application, you don't know exactly the name. If you start to throw some of the keywords, it can proxy to you and you can find exactly what you want. The next step on those applications is already under development, is by just snapping a picture of the product that you're looking for, the AI and the computer will be able to find exactly which part you're looking for and connect you to that. So you can formalize your purchase, you can execute the purchase. Think how that could relate to crop disease in greenhouses. So by the image analysis, if you can find some symptoms and signals of disease that could already identify what is, and just make sure you have all the recommendations on how to treat, and you get this early detection signal. On banking, for example, AI is used to search for anomalies on large sets of data. So you're just processing large sets of data, and if there's something abnormal on the transactions, they know that's a signal of fraud. So they can early detect that, and they can provide all of you safe. I bet again, most of you at least one time try to make a purchase, trying to buy something expensive, your card get blocked and you have to unblock. That's the safest because they saw something abnormal on your history and use of the credit card. So if you think about this, how that could be applied for the daily operations in greenhouses. So if you have all this AI taking care of the routine measurements, growers could be spending their time looking for something more meaningful and really thinking how to optimize the entire production system instead of spending time on these routine measurements and searching. You leave the computers to look for the abnormalities, and you can spend your time just developing more strategic tasks. On the finance, I think those are good examples as well. AI is used to predict market trends and foresee future transactions. So based on past data on how the market reacts, it can foresee what would happen if that situation shows up again, that scenario shows up again. We can think of those applications in a greenhouse. You can apply for the weather forecast, and then you can try to predict what will be the yield production in a few days, a few weeks from that day. So you can do these predictions based on past data, and you can make all the correlations that would be very hard for the human brain to do on its own using large sets of data. We could also look for past data to predict patterns. So if there are patterns that you can see on your crops, some traits, or even on the weather again, on the conditions, if you start to see some patterns that have been identified before, it can be an early signal for the grower to change or at least to adjust what's gonna be happening within the next few days. That also leads to some of the logistics, not only the production, but the logistics. You can think about prices of inputs. Some of the prices spike. What are the reactions on the market of your crop price? So if the crop price is changing on the market, you could make adjustments to accelerate or hold on your production so you can get higher net profitability. You can think about trucking, shipping, suppliers, vendors. So you could use the large data sets to optimize all those systems as well. So some of the applicabilities of AI. Now, why I'm talking about the AI itself on webinar to incentivize people to share data? Because in US, we are sit on a huge amount of data, which is being very underutilized today. If we think about the amount of research institutions and commercial greenhouses and vertical farmings that are collecting large amount of data today. We're already collecting environmental control data, for example, for temperature, ventilation, humidity, the screens, artificial illumination, CO2 concentration, irrigation. Those are the environmental data sets. Almost all of those are collected today through the sensors. So it can collect large amount of data and it can buy a large amount of data. And there's also the crop production parameters that can be analyzed. Crop production yield, quality, color, sugar, size, length. If we can get all this data, which are already collecting, but we're not using, we are set on a very high pile of valuable information, which is just scattered right now. Why should we use this? What can we use with this data? Through data analysis, if we can have a centralized platform, we could centralize these thousands of data points. They can be on a standard format, then now they can be compared, they can be used and they could be shared. Outcomes of that would be improving production efficiency. I think that's the bottom line of the AI, which requires data sharing. If you can use this data to train the AI algorithms, and then the AI can work to increase net profitability or to increase sustainability, that's the bottom line that we want to provide the industry. Production management, that's something that I mentioned a little bit just on the previous slides. And that's tied together with the next point, which is expanding employee capabilities. If you can remove some of these routines, tasks from the growers and let them to concentrate on what's really important, that can also help to solve a little bit of the skilled labor problems shortage that we have today in US. So I have here on the screen as well some of the benefits and some of the examples. Now, what are the challenges that we see that are trying to overcome? It takes time for these self-learning technologies to learn those patterns, specifically for the specific crop requirements. We have several different crops in US. There are several environmental factors influence AI algorithms development. So we need large sets of data that can be used to train the AI algorithms, the machine learning, and just get the big data analysis done in a meaningful way. And there are many external factors that play an important role in the system's decision-making process. That leads me to my next example. We have a lack of models in US. Here I'm talking a little bit a more broad range than what the data sharing today is, just to provide a picture of the scenario today. For example, in Japan, they have very good models for vertical farming, and in the Netherlands, they have very good models for the greenhouse industry, which includes all these factors here. It includes, if you want to complete a complete economic model, it includes labor, so how much costs labor and the availability of skilled labor. Economics, the prices of all your inputs and how much you're selling your produce. Cultural factors, for example, product pricing, how much the market is willing to pay for the produce. The market itself, how it reacts with the other factors within each one of those economies and these environments. Perception, value, here I'm talking about what is the perception of the consumer on your produce or product if you're growing ornamentals. And then lastly, the 2 points that we want to talk today, the production itself. So what is required to production within the greenhouse system and the environment around the greenhouses. And that leads me to the main point of the talk today, which is the establishment and creating awareness of the CEAOD, which we're calling the Controlled Environmental Agriculture Open Database Project. So we're working with the team of researchers that we saw at the beginning, the multidisciplinary task force. We're establishing this open database, which is free, is now hosted at GitHub. So we want the open database to be free for everyone here in US. And we want to concentrate as much data as we can under the US conditions. The 3 basic steps that are working today, and I'm gonna just do a brief overview and Ken gonna take from here, is the data formatting recommendations. So how we can collect and we can register the environmental data set, the biological data set, the crop production, and the metadata, documents describing the experiments. How to use the open database, so the data repository, which is the CEAOD. How can you upload these data sets to this platform? And then the last part are the tools that we develop. So then anyone can really explore this data, can do a lot of data analysis and exploit the data as well. One time you know what you're looking for, how to benefit from those data sets. But the main and first step is to share data. So we have to create awareness and we have to work with the research institutions and the commercial companies to create this awareness of the importance and incentivize everyone to share the data. I'm going to stop here and I'm going to leave Ken take from here for a demonstration. Ken, I stopped sharing my screen. Can you take control?
Yes. Okay, let me share my screen. Do you see the right screen now? Do you see my screen?
Yes, we see the right one.
Okay. So hello everyone. And thank you, Erico. I would like to continue the presentation with some concrete details about the platform and how you can contribute sharing your data. And this is the the outline for my presentation. So first, I would like to spend a little bit of time introducing myself and our company. So as I mentioned, we are an ad tech startup, and I'm the founder of this company. I was recently a scientist at Microsoft Research, and our company basically helped greenhouse and indoor farm growers to achieve more, increasing the production efficiency, etc., using the combinations of AI, IoT, and also plant physiology. And about myself, I was previously at MSR, and as Erico mentioned, in 2018, I led our team, the Sonoma team, win the first autonomous greenhouse challenge, and we were the only team that actually outperforms the Dutch growers with 17% higher net profit. And previous to that, I was basically from the AI background. We did a lot of work for Microsoft, including Project FarmBit and computer vision work and reinforcement learning for different control applications. So what does Quadra do? So we help make the greenhouse and indoor farms more autonomous, not just more autonomous, with higher yields and less resource usage. So now, I would like to. So Erico already mentioned the motivation for CEAOD, or Control Environment Agriculture Open Data. So I would like to go through the steps. First, I talk about the data format recommendations, about how you can upload your data and how you can download your data. And then I will show you one tool that we have to explore and analyze the data. So this is the CEAOD website. And I am on the data guidelines page. So this is about, so this page describes our data formats recommendations. And this is the same data format that we actually used when we worked on the autonomous greenhouse challenge. And as by the results, it did work well for us. So for a complete data set, we need at least 3 of the following data files. So we need 1 or more table for the environmental data, 1 or more tables for the crop or biological data, and 1 so-called metadata file. And the metadata is just a text file that describes your data set. And why we have these separations. So for the so they have different characteristics. So the environmental data the data usually comes from the sensors and the actuators, and they come in at very high frequency. So this is an example that I'm showing here. So as you can see, and this data actually came from the autonomous greenhouse challenge that we did. So the data comes in every 5 minutes. So it's very high frequency data. So in this data, what you typically measure is, for example, the temperature, the relative humidity, CO2, leaf temperature, whatever that your sensors can measure, then you should put them in here. And I would recommend that you put them all as a single data table. And then we have another table for, so you should have at least 1 or more tables for the biological data. And what characterized this data table is that the data frequency is low. For example, so if you measure the harvest data, you input it at the maximum once a day, not more than that. And these are inputs by the humans compared to the environmental data. The data here is really inputs automatically by the sensors, and these are registered manually by the staff or by the growers. And then and then you should have a description file, or some people call metadata. So in this description file, it it can be a Word document, or it can be just a plain text document. And in this description file, you should provide at least some brief description of the data, including the dates, location of the crop, something about your experiments, and you should also describe the sensors that you use to measure these attributes. What kind of sensors did you use, the models, etc., and also the units for each attribute that that you provide here. For example, this is the number of leaves, etc., or this is the product count. So what is the unit of that? So for the unit information, you should put in the metadata file. You should provide the data owner and contact information, of course. And if your data is used for a publication, then you should also include your publication as well, which is good for citations. And if you have all the information that you would like to share, then provide the funding source, specs of your instruments, etc. So let me show you an example here. So this is the data set that back in 2018 Microsoft Research, which I led, the team that I led at the time, contributed this. So we contributed our data sets that we collected from the Autonomous Greenhouse Challenge. So this is basically our metadata. And then we also have one table called crop. So this is our crop data table. Looks like this. And if you upload it on GitHub, the nice thing about GitHub is that you can sort of view the data directly on the website without having to download for simple data. So for the environmental data, the file is big, so GitHub cannot display it on the web. So so for that one, you need to download. And then for the tabular data, we recommend that you use the CSV format instead of using Excel. The reason for that is that CSV is a text format and Excel is a binary format. And so for text format, you can, so as I have just shown you, so the website can render a CSV table. It cannot render an Excel file. And using the text format, like in the CSV, we can track the change that you have made. For example, if you made some errors, there were some measurement errors, and you want to modify, you want to update that, then we can also see what change you made to the file. And using CSV, it can be opened in many programs, especially for cross data set analysis, while Excel is fairly limited in that way. And as I have just showed you, we can also glance at the data from the browser. So that is about the data format recommendations. Now I would like to go to the next page to describe how you can upload your data. So so for those who have tried to upload the data in the past, I would like to inform to you that we have recently revamped the instructions page here to make it more friendly. So in order to, because our data is hosted on the GitHub website, which is a widely used open source platform. So you need to have a GitHub account in order to contribute your data. So the first step is very straightforward. And then in the second step, so what does fork mean? So you need to fork the data repository. And in GitHub, fork just means that you are just copying the data, you copy the official data repository to your account. And from your account, you can modify the data however you want. You can upload your new data, and no one would complain about that. So you can do everything within your own data repository. And after you finish, and for uploading, you can just, for example, this is an account. This is a fork. and then you can just drag and drop. So you open your Explorer, you drag and drop your data set directly to the browser, and your data will be uploaded. And then after that, you need to commit change. And when you commit, it means that yes, you are happy with the data that you have uploaded. You would like to use that version. And then the last step is called the review request. So in order for your data to be incorporated into the official data repository, it needs to go through a review request. And when we review, all we do is that we just want to make sure that you follow the data format recommendations, and we provide some recommendations, other recommendations that you can, so that you can improve the clarity and the completeness of your data. And that will make it easier for the users to download and to use the data later, because we don't want to have just one bin where everyone can upload the data freely without any data format consistency. So that's how you can upload the data. And if you have any questions later, if you have any trouble, feel free to contact us, of course. And if you want to download the data, then from this website, from ceaod.github.io website, just go to the download page. And from the download, you can explore different data sets that are available on the website. For example, we have, this is the data set that we mentioned about. Before LumiGrow also contributed one data set. And interestingly, I will talk about that in a bit, that this morning I also received a review request from Plenty. So Plenty is also providing their recent data, which is very interesting. So from the download page, you can go to the relevant folder, and we are currently organizing the folders by the structure, followed by the crop. And structure can be either greenhouse or vertical font or something else, and then followed by crop. And that way, by organizing this way, we can easily compare different data sets later for your analysis. So this is one example. So we have the cucumber data, and we have the, for example, this is the data sets from the Autonomous Greenhouse Challenge, and the data set was published by the organizers, and there's a publication detailing that data set as well as the competition as well. It was published in 2019. So we have multiple experiments, similar experiments in this competition. So using this format, using this structure, it's very easy to do the comparison. So that's how you download the data. And yeah, I just want to show you here that so this morning I just mentioned that Plenty they want to contribute, they want to share some of the experiments in a vertical form, in their vertical form. Okay, so next I would like to show you the tools that Quidra has developed to do the data analysis. So because we have multiple data sets from the autonomous greenhouse, so we can draw the charts, we can do the visualization here, and we can click on, we can compare the performance by different teams. For example, the Microsoft team here, or the reference growers here, and to see how they did differently. So this is their crop performance, and then we can also go to the, for example, the climate. So we can see how different growers or how different teams chose different strategies and what they did. For example, looking at this, we can see this is the lighting strategy by by the growers, and this is the screen strategy by the growers, the temperature and humidity here, and then we can go back to here to see how the Sonoma team did differently. Okay, so that is just one use case for using the data sharing. So next, because Erico has mentioned the autonomous greenhouse, and then even though this is about data sharing, we have received a lot of interest and request to talk about the autonomous greenhouse challenge. So within the context of this webinar, I will just talk about this very briefly. So I'm going to skip this slide because Erico already mentioned that. So we were the only AI team that beat the humans, in this case the Dutch growers, with 17% higher net profit. And you can see this is me on the final day. So Erico already showed you this, so I'm going to skip it. So I'm not going to talk more about the autonomous greenhouse challenge because that's not the focus of this webinar. But if you want to know more about that, then we will organize, and Thierry Kubota will organize a forum. It's a webinar format, but it's a 2-hour forum on this topic at the end of this month. So keep that in mind if you want to know more about the topic of autonomous greenhouse. So as I have showed to you, by we have demonstrated how we can display it. So using this open data platform, we can host the data. We can show how to do the data analysis from different data sets. And this is the image from our trial during that autonomous challenge. Okay, so last but not least, we welcome questions that you have during this webinar, and if you want to ask more about either data sharing or any other topics about autonomous greenhouse, about AI, about data science, anything about CEA technologies. We have recently, and this is very new, put up a forum called CEAforum.org. Why don't I just click here? Hello, Erico, are you still seeing my screen?
Yeah, it's also mute. Sorry. Yes, it's saying that having trouble finding site. That's the screen we're seeing right now.
Okay.
Now we're to the last but not least.
Okay, so go to the CEAforum.org and perhaps add the HTTPS. So let me try that one. Yeah, this is something that we will need to fix. Okay, that works. So this is just a completely new forum, and it went live just this morning. So you can, if you have any questions, you can just add questions here. On the topic of data sharing and data and technologies for control environment and agriculture, we will have an ASHS workshop next week, actually. So we will talk more about this. And on behalf of Erico, there will be the next place seminar in late September. And so with this presentation, I hope that more people will contribute their data to the open data platform. And thank you. With that, I would like to welcome your questions.
Thanks, Ken. Great demonstration. It's a lot of information in a little bit of time. While we got the questions, I think would be nice to just reinforce what you mentioned. We have a presentation scheduled for the American Horticultural Society for the open source database. So it's a workshop where we're going to be demonstrating how to do this step by step again. So it's more hands-on. People will be able to see how to upload the data, download the data, and all these applications. I would like to start with a question, Ken, for you, which is, we're talking a lot about the importance of data sharing. So we did see a lot of the benefits that we can achieve with the AI. You talk about the autonomous greenhouse challenge, where the AI control algorithm has now beaten the Dutch greenhouse growers on the field. Why is the data sharing so important in your view? Why should it be contributing this data? Because we do have a lot of data in the US with all the researchers, the company. Data is available, but we are not taking advantage of all these data sets. Why is it important for people to be sharing the data, and how the community can then benefit back from this data sharing process?
Okay, so first for the researchers, there's an increasing request from the publications to publish your data that accompany your research. So this is something that you need to do anyway. And we provide, so you need to share your data that accompanies your research. And with data sharing, then we will have more data. No one can have the data. No one has enough data. So if you are a grower, then you typically stick to one growing strategy. You may collect a lot of data, but your data is not diverse. So it's just like one kind of data that you are collecting every year. Like your data doesn't. So you don't get to see much like what will be different if you do it otherwise. So by sharing the data, then we increase the diversity of the data set, and then we can advance our joint understanding about what would be the best, for example, the best growing strategies, and we would advance. We can build the simulators, or that Eriko has mentioned. So the Netherlands, they have a very good simulator, and they have accumulated a lot of data. And likewise, Japan also has a good simulator for the vertical farm. Here, we don't have a similar tool in the US or for the world. We don't have anything that is accessible to researchers, for example, like me or like Eriko or like many others, not at Wageningen University research. So we need to share the data so that we can build the models, and then we can validate the models against the data, and that will help push the field forward more rapidly.
And I think that would be, as you're talking about the models are very important. We received some feedback prior to this meeting today, to this webinar, which is someone that is establishing a new facility. So I think with this data, if people share a lot of data, you could use both for new applications, right? For just setting something new, you can get a good sense of what will be necessary to achieve your goals. But like you mentioned, also, if you already have a facility, all the simulations you can do, how to improve your facility based on data, right? And lots of data, cross information as well. I think some of the things of the autonomous challenge, I saw some publications afterward comparing the approaches. And it was interesting because they were saying if, for example, team A used team B lighting approach, they could have saved X amount of dollars, or they could have achieved X amount more of profitability, or yield could be increased. And then you combine lighting with CO2 control and other factors. So those are very large data sets that only by people sharing, right? Like you mentioned, you have a snapshot on what you're doing in your facility. But if you really want to explore, we have to share this data. And then to that point, Ken, how people can really benefit. So how can a grower benefit from that, for example? A grower who does not know how to download and analyze the data. Other companies will do modeling. How does that get to the grower at the end of the day?
Okay, so there are multiple types of growers. Some are more tech savvy and some are less tech savvy. So the ones who are tech savvy, they can download the data. So so the first benefit is that they can learn from the best practice. So, and we provide the best practice for how to save the data, and they can look at how other people save the data and learn from that. And when they share the data, they also learn from they would their data sets would go through a review process, and we help them um, store their data in a better way by going through that upload and review process. Because the data, in order to take advantage of AI or machine learning data science, the very first thing that you need to do is that you need to have a proper data management uh, infrastructure by collecting the right kind of data, collecting and saving the data in the right way. Uh, uh, and just by sharing your data, you can the process can help you improve your data management already, and it helps you recruit people as well. So it will attract people who good talents who you may want to hire to work at your company.
You're right, and I believe that's somehow new for this field, for the controlled environmental agriculture, the AI portion. We've been using sensors for a while now. I think now with the sensors become more feasible, so they are cheaper right now. They have higher capabilities. They can collect more data. They can process more data. I think sometimes you can even got lost on all these huge amounts of data. We're collecting all this information, and like growers would graph, and they're gonna look for the main parameters that have been historically have been analyzed. But I think now with more capabilities, especially as the equipments become more capable on its own. So if you have more energy efficient equipments, then they are more flexible, they can do different things. For example, now lighting, there's a lot of advancements on lighting, different spectrums of light. And then if you can control the light based on the environment in conjunction with the CO2, now you have to control your ventilation at the same time, so you don't blow up your CO2 that you just enrich to take advantage of the lighting, and then you have temperature control. I think when you have these very large sets of data, the AI could really help. And that goes back a little bit to the example that I gave with the chess at the beginning of the presentation, how the computer can, like a human, make decisions on sets of data and narrow down the most favorable paths and analyze huge amount of data. And I believe we're gonna come to advancements and solutions that we couldn't think of before, now that we have this computing power as well. So yeah, go ahead.
Yeah. One important point that I have just remembered, and I think I should mention it, that I have talked to many growers and they collect data, but not the right way, and they don't know how to analyze the data. The data just sits in their climate computer, and and so by sharing the data, you and so basically there are so many unknowns. You don't know what you don't know what you don't know. So by sharing your data, you get feedback from the community whether you are doing the right data management or not, whether your data is complete or not complete, and maybe you need to add this sensor or that sensor to help you grow better. So when you share the data to the community, you get the back from the community on how to improve your data collection strategy and your data driven growing strategy.
Right. Yeah, and I think that's important. If we can get a few people that really wants to collaborate and become involved with, because that's an open source project you mentioned at the beginning. Even in the Netherlands, for example, that's not available right for everyone. I think what we're trying to do is pretty innovative. Everyone can benefit from that. Everyone can collaborate. So getting all this multidisciplinary knowledge and expertise can really help this field when we're bringing out data scientists with growers and researchers and commercial companies. Really, hopefully everyone can benefit from that. And I really would like to see, as you get more data coming into the database, we could start to generate some case studies and demonstrations. So then growers and everybody, all the stakeholders can really grasp the potential of this technology. I think if people start to see what can be done with that, so examples like you did with the remote, the autonomous greenhouse challenge, by beating human growers and then explaining how that was made, how we can analyze the price of input and make those connections with the profitability. By generating most of those examples or more and more, hopefully going to get more and more interest. One thing I would like to mention is that with Glaze now, for the next 2 to 3 years, we have dedicated some funds, human resource and funds to collect data on our experiments over the next 2 years. And we will create a guide based on our experience, how we are collecting the data, how we are uploading the data to the CEAOD, the open data platform, so we can create this guide and really incentivize other researchers. I think researchers could be a great first crowd or first audience to help us. They're already collecting the data. They know how to collect the data. They have the students that can help do that. So hopefully we can incentivize our goal to get 10 other researchers to share the data. And if more people on this call really sees the value, please get in contact with us afterwards. I will be happy to provide more information and let you know how to share the data and provide some more of those benefits. Perfect. Ken, do you have any final thoughts? I don't see any other questions coming up. We got one comment when you were presenting, you didn't see that, but when you talk about the next webinar, the why, how, and what, I believe, or why, the one you're going to be talking about the experiment. So you got one, yes, please. I think you have at least one people signing up for this webinar. So that'll be good. I think people would be interested in understanding how you actually control, how you do the autonomous greenhouse control, the actuators, the data collection. So do you have any final thoughts, any final comments, Ken?
Yes, so I would like to make a quick comment on that autonomous greenhouse forum. We are still putting up a website. Thierry Kubota is doing that. So we can send more information to the audience of this webinar later when we have a formal website up. But for now, just keep the date in mind. So that will be August 28th.
Okay, so there is no signing so far?
No signing up, no sign up so far. But that will be out soon. That will be out very soon.
Okay, where they can find for information, is that the website from Cherry?
I will send it to you, Erico, so that you can contact too.
Yeah. So I'll post. I have the list of everyone that registered for this webinar. I'll follow up with that information as soon as it's available. So for those of you who ask about more information on this presentation, I'll let you know as soon as I get more information from Dr. Thierry Kubota and Kenneth Lamb on that.
Yeah. And I hope that, so one final comment is that I hope that after this webinar, we will have more people contribute their data to the website, and once we have a vibrant community and contribute a lot of data, then that's when we will have more exciting research and more advances. That's when we will realize AI in CEA even more.
Ken, we got one last minute question here, which is, does the CEAOD data format plan incorporate the FAIR data principles in its format? And FAIR is the fair, accessible, interpretable, and open. Are you familiar with this acronym?
Not necessarily. So if you can you share the questions in text so that I can read it?
Yeah, there is a link here to that. I am not familiar with that as well, so I will follow up on this afterwards.
So the FAIR, I don't know about FAIR. I don't know about FAIR data principles. I don't know about that website. So I don't know. But according to, it's certainly fair. It's certainly accessible. It's so whether it's interoperable is up to the data contributors. So if you save your data in an interoperable way, then it is interoperable. And well, this is interoperable, yes. I was thinking about interpretable, and it's certainly open and accessible to everyone.
Yeah, so I think the answer is yes. I got the link for, well, thanks for sharing this link. We're going to take a look on that a little bit more. Maybe we can anticipate this question next time. So for the next presentation, you can already start to use this definition here. That's a great question. Perfect. All right. Well, Ken, thank you so much for the presentation. I hope everybody here today on the audience enjoy the talk today. We look forward to see you on the next Glaze webinar, which will be held on September 24th at 2 p.m. again, and it will be about food safety in CEA systems. The presentation will be performed by Joya Massa from NASA and Marnie Carlin. She is the executive director of the CEA Food Safety Coalition. So it'll be a very interesting talk about food safety, on what's been done in the research environment, and also what's happening in the industry with the director of the Food Coalition.